So this is the common data, and we'll follow the same line parameters, these values, and to solve the numericals one by one. Okay. So um, so it's given a 400 kV, 800 kilometers, 60 hertz, three phase, symmetrical, lossless. So this is the common data. Okay. Based on this data, we'll solve the numericals. Okay. So I guess it's clear and visible. You may note down the data and we'll solve numericals one by one. So is it okay? Can we start the questions?
Yes, you've noted that.
So the question one, line search. So this is the first question. Determine the line search impedance. So this is the question that we were discussing. So this is the common data, and using this data, we will solve this question. So the options. These are the options. So So for lossless transmission line, C, yes, C is the correct answer. C is the correct answer. So let's solve it fast. So ZC is root under L by C. So L and C are given, right? So L and C are given zero point 0.8 and 12.1 nano. So one is milli and other is nano. So directly we can 0.8 into 10 to the power minus 3 and this one is 12.1 into 10 to the power minus 9. Just if you solve, you will get this answer 257.17. Simple problem. So question number 2. B, option B, right? Yes, option B is correct. 622.25 megawatt is the right answer. So given that such characteristic impedance value we have known, so with that we can easily find out the value of such impedance, right? So let us quickly solve. So this here which is required to calculate the surge impedance loading. So we may term it as ZC is from there we are getting. So we may refer this as TC and already the voltage is known. So this voltage is given as 400 kV. So 400 kV. So one thing we can directly, what sir has also detailed during the mathematical solution or numerical example that he has given, that since generally the surge impedance loading is detailed or is generally given in megawatts, so we can directly, if we do this square, so kV term, so a direct megawatt value we can directly obtain from this PC value, right? So we can directly ensure that this is we are obtaining the result in megawatt, and directly we can put the answer by considering for a kilovolt square. So characteristic impedance will be 57.1. So if you solve this, so the answer will get as, so question three, determine the phase constant degrees. Okay. So options are So which one is phase constant, alpha or beta?
Beta.
Okay. So, and what is alpha known as?
The real part of the
Real part.
that
What is
expression.
the terminology used for alpha? Means what is it known as? It's like phase constant. It also has some name. Okay, no issue. It's known as attenuation constant. Okay. Alpha is attenuation constant and beta is phase constant. D. Yes, D is the correct answer. So for lossless line, it is generally known that for lossless line, so this constant or say beta is given as omega root under L square. Right. So omega value frequency is given 60 hertz. So 2 pi into 60 into root under LC. So L value of L was 0.8 10 to the power minus 3, 10 to the power minus 3, and C is 12.1 nanofarad, minus 9. So this the answer is required in degrees. So if you solve this value, you will get the value in radians per kilometer, rad per kilometer. So now the question is phase constant in degrees. So we will have to do beta L, right? So for 400 kilometer line, so the phase constant is sorry 800 kilometer line. So 800 kilometer line. So what will be the value? Beta of beta L. Beta L becomes per kilometer. This is rad per kilometer. So for a whole total length, it is 800 into this value 2 pi into 60 into root under 0.8, let's keep so 10 to the power minus 12. So outside it will 10 to the power minus 6. So the final value, so it is outside this 2. So minus 6, so you will get the final value. This value is in rad. So to convert from rad to degrees, we will have to just multiply this beta L value, just plug in this beta L value, this beta L value, so to get the answer in degrees, just this beta L, that value we are getting from here, this is in radian, so into 180, so final value we will get as 50. Is it correct? The procedure?
Yes.
Ah, so you will get this value. So I have not gone into the calculation. So I hope you will understand. This is the final answer. So moving on to the next question. So rated load of the line. So options are, so all these answers are in megawatt. Rated load of the line is required to be calculated. Yes, B is the correct answer. So rated load of the line is to be calculated as, so rated load of the line, we can say it means active power, megawatt is required. So P rated can be given as voltage. So line to line voltage is given by ZC sine beta. So V square it is given sine, and delta I guess some delta will, yes, power angle is also given 60 degrees. So sine delta. So real part. So real part. So on sine delta, sine delta. So if you, so V is 400 square by ZC, we have 200 something, right? 257.1 2, and sine beta L value also we have obtained, it is 53.77. So beta L is 53.77, and delta E is given as sine 60. So sine 60. So here separate beta L and the calculator. Yes. So once beta L we have calculated, so the final value you will be getting as value stated. So is 668 point something. This is the correct. So, question number 11. This is the question. So options. So determine the reactive power at the receiving end, considering the symmetrical operation of the line and no load condition. Line and no load condition. So the the condition for symmetrical operation, I guess it's clear, right? So the assumption being the lines being symmetrical. So here we get ease out in solving these problems. So what's the effect of lines being symmetrical? What is the channel also stated?
Sending end and receiving end voltage is same.
Yes, yes, yes. E. Yes, this is the right answer. So reactive part, we have the direct formula. So, but at the receiving end, so you should be keeping this in mind. And lines are also symmetrical. So accordingly, and no load condition. Condition is no load. So for that, you you will be given as DLL line to line square, and here ZC sin beta L. This one is fixed. So inside bracket, there was only sin delta in case of real power, but here it will be cos delta minus cos beta. So this is the value. So if we calculate, final value is 400 square, and cos delta is, so at the receiving end side, so delta would be 0. The receiving end side, delta would be 0. And cos beta L we already have calculated 53.777, and ZC already we have calculated 257.13, and sin beta L is sin 53.77. So if you solve this, you will get this value of 302.4. I would hope, yeah. So this was from receiving end, but now what we need to do is question number, I guess, 6. So determine the reactive power 400 kilometers from the sending end, considering so this is the question. Options are, so determine the reactive power at 400 kilometers. So that means the line was 800 kilometers. So 400 kilometers it would be uh, x, some value of x. Okay, A. Yes, A is the correct. A is the correct answer. So, so can you please see is 0.
At the midpoint, it is reactive power is zero.
Yes, yes, at the midpoint. So this is the, although we have the expression, means if this value would have been somewhat between 200, 300, some value would have been there, but since it is exactly the midpoint, so we won't have such values. It will be 0. Nice. It was a tricky question, that's why it was there in the, but still the expression, if you want to see the expression, so solution would be, so line, total line, 800 kilometers. Um, and the reactive power from the receiving end is required at exactly total line length divided by 2. So Q will be, also the expression if it is required, so the expression is given. I can mention, I'm also writing the expression of qx by seeing because such a long expression I also so qx is bf square equal sine q beta l minus beta h minus 2 bs line to line and gr line to line multiplied with cos delta into sine beta l minus 2 beta. Actually, this one is a single term. We can write again a minus here also. Gr line to line square sine 2 beta h. So this is the whole expression and divide by 2 zc line. So this is the whole expression at value x at any value x, but since it is midpoint, so we will get the value is 6. So the question is determine the active power flow in per unit at 250 kilometers from the receiving end side of the line at a load angle of 30 degrees. So base power and consider the surge impedance. So that is the last step. So yes, this is the correct answer. This is a simple problem. So already active power is P can be calculated. We have seen here. V this one V line to line. Uh, yes, this V line to line. Z by ZC sin beta n multiplied with sin beta n. Where sin delta and ZC sin. So if you multiply V L to L, that means 400 square. And sin delta means sin 30. And here is ZC value 257.1. And sin beta L is 2.77. Yes. So this is the value of P. Now this value of P is not in per unit. So if we refer P in per unit, then this value. C we have also calculated. Yes, this one. Determine the rated load of the line in megawatts. So 668 point uh, at the value of X, right?
Sir, all this will not be necessary because active power anyways is constant throughout the line,
Yes.
and
Oh,
it
okay.
since
Yeah.
it is base power, so it will just be sine 30 degree by sine 53.76.
50. Yes. Yes. So in that case, so P correct. What will be the value? It is the if the per unit value base power is given as surge impedance loading of the line. What you are telling?
Yes, I was saying that this VL square by ZC value, that is the surge impedance loading we've already calculated. I think it is
Yes.
622.25.
What was the value? 6,
22.25.
622.
Yes.
Okay. So we did it previously, right?
Yes.
620. Yes, this one. This value will need to just plug in there, right?
Yes.
Then only we'll get the answer.
Yes.
So in that case, we can directly, so everything is getting cancelled out, right? That was the point of saying that. So this
That's
value,
correct. Yes. It's
yes, yes.
same only. That's what.
So this value are getting cancelled out and, okay, okay, yes. So sin 30 by sin, yes, it is independent of the kilometers. So, okay, okay, yes, yes, now it's there. So I think this will also give the same answer. Right? This is the same thing.
No, because the angle is 30 degrees. In the other one was 60 degrees, the power
Oh,
angle.
okay. Yes. In that case, the load angle was 60 degrees. Oh,
Yes.
yes. So this answer would be sin 30 by sin 50 equal to the value will be 0.60. Thanks. Okay, so questions, question number two. Determine the value of the load angle in degrees when the line is loaded with surge impedance. So simple question. Yes. So C is the correct answer. So when it is given that the line is loaded with the surge impedance, so what is the SS equivalency that we obtain in the form of active power?
Sine delta by sine beta L equals to 1.
Uh, that is also a part. Yes. Sine delta. That is the final value. Sine delta and sine beta L equals to 1. So both are same. We can, this one is for the load angle in degrees we need to calculate. So in that case, sine delta and sine beta. So directly we can say delta beta L. And already beta L we have calculated 53.33. No, 50.7. Answer is here. So this is the So determine the reactive power at the sending end in per unit, considering the symmetrical operation of the line at loading of 45 degrees. So base power is equal to SIL. C. So you are required to calculate the reactive power at the sending end in per unit, considering the symmetrical operation of the line at the loading of 45 degrees. So
Sorry, B.
yes, value is correct.
Minus.
So let's solve it first. So given symmetrical operation, so what we can do is that reactive power at the sending end. So in sending characteristic. So answer is required in per unit, right? So directly we can get the value in per unit. Mm, was detail. So when we get these values, sorry, the other value is cos delta. Minus value is cos delta divided by sin beta L is fixed. Since it is required in per unit, so now cos beta L is cos 63.77 and cos delta is 45 given 45 is cos 45 and sin beta L is so this is the value that was right. So determine the reactive power at 200 kilometer. Now the system is not symmetrical one or midpoint, so you have to calculate. From the receiving end side, considering the symmetrical operation of the line at no load, so these are the options. So we went 200 kilometer from the receiving end. So the formula that we have discussed once, but the question was for the midpoint, and that's why we didn't dive deep into the problem. But the formula that is to be used here, we have written it. for those who don't have the data and the data based on this is the common data. So usually for people who were from the very beginning, so this is the same data we are using repeatedly. This is a common data set. This is the data set and it's data. If you are willing to take a screenshot, you can and solve the final problem. Uh, Formula also, this is the formula to be used. C. Yes, option C is correct. Yes, option C is correct. So, okay, then since one already solved, so we won't wait much and we'll start solving it. And so this one was the reactive power. This was the from the sending end, reactive power equation from the sending end, right? So it's from x distance from the sending end. Okay. So this is x distance from the sending end, and qx is given as refer to the keep it here also. So vs line to line and beta L minus beta x minus r square line to line sin 2 beta x minus 2gf line to line r line to line cos delta sin beta L minus 2 beta x. This is whole divided by 2 z square. So just plug in these values. So this is from the sending end, right? So and in the question we have to find out 200 from 200 kilometer from the receiving end. So that means 600 kilometer from the sending end. So this may be equivalent to so 200 200 kilometer from the receiving end it is required. Is same as 600 kilometer. So this is the basic understanding, just simple subtraction. And with this, we'll just plug in those values of x. So ds, value of ds is already beta x we need to calculate first, because beta l we have the value of beta l as beta l value is 53.77. We already know that. But beta x we need to calculate. So we can beta value, I think we have beta value we have calculated once. It is value. Okay, we haven't calculated. So beta x will be, what we can do is that, so beta x value, x will be 600 here. So beta value have you calculated? It will be in radian per kilometer.
Yes, beta value I can say it's 1172
1172.92
0.92 into 10 to the minus 6.
Okay. Okay. Thank you. Thank you. So this is in rad per kilometer. So this will be beta. So therefore beta x will be, we'll have to multiply with 600, and we'll get the value of beta x as, the value of beta x will be
In degree, it will be 40.322.
40.32. Thanks. Thanks. So we have these two values. These two values we have filled: beta x, beta l we know, and ds, dr we know these two values. So everything is done. So again, beta x is done, beta l, beta x done. Okay. Delta value,
No
delta
load, so
no
0
load.
degree. Uh,
So so for no load condition it will be,
0.
yes, yes. So so delta value is equivalent to 0. So we can write it as here again. Delta will be 0 since no load condition. So all the values we have now, just plug in those values. So q x at, say, at x equals to 600. So will be 400 square, the sine of 2 into 52.77 minus 43.322, and minus dr square. So dr square is again 400 into sine 2 beta x, sine 2 into 40.322. So, and final one, minus 2 into ds dr. 2 into ds dr is again 400 square, and cos delta is 1, and sine 1, sine beta L. Beta L means 53.77 minus 2 into 40.3. So that is the numerator part. So 2 into, yes, 2 into, okay, fine. So this is the numerator part, and for the denominator part, it is 2 into ZC. So 2 into ZC is 2. 257.1, 257.1 and sine square beta. Sine beta L means beta L means so that's it. So this will yield the final value, and it will be 176.83, 176.83 m naught. So this is the okay. So I hope it's clear. So these numericals are solved. So for the long transmission line, one concept Sarah's detailed. So there are few numericals, one or two numericals we can solve from there. And sub numerical, which one numerical which has many subparts. So from the ABCD parameters also. So we can um, first one or two expressions will see, and based on that we will solve some numericals, because this type of numericals are quite obvious in case of semester, does not semester, final exam. It's kind of semester exam only for this entire course. So most of the equations are known, so we'll just have a brief overview of the. So let's keep this page blank. So already these things were detailed. So we have long transmission line only. Since we have time, okay, so that's why. So one expression for which voltage expression we have, right. First of all, the characteristic impedance information you all know is Z by Y. For lossless, we have the additional part that the line will be lossless, so the R and G values will be negligible, which will have no effect. And for the gamma is given as root under Yj, right? And based on that, we solve the values alpha plus j beta. So alpha being the mentioned attenuation constant, and beta being the phase constant. And what is gamma known as?
Phase
Gamma,
constant.
no, phase constant is beta, and gamma is beta for lossless line. So in those cases, we can consider gamma as phase constant because it bears the same value, but it has a different name. Okay, so it is also known as propagation constant. Propagation constant. Okay. So propagation constant is equal to phase constant when in the line is lossless. So in that case, it's a special case of propagation constant being same as phase constant. So we may consider gamma as also phase constant. But okay, so this is one part. The final expression. So I hope you remember the final form of the expression for long transmission line. So I'm not going that detail because it will take much of a time. So final for long transmission line. So in that case, Z, Y, and V. So this is the differential equation based on which we obtain the value of voltage. So we consider the voltage. I hope sir has also derived. So I guess you can also remember gamma x and plus b into e to the power minus gamma x. I hope you can remember this type of derivation sir has also done.
Yes.
Yes. So these are the basic formula. Based on this, we'll solve one numerical which has subparts too. Okay. So this is one part. So and similarly, the current for the current uh, equation, final current equation also we have derived, right? So current equation becomes I by ZC, and here it is A e to the power gamma x minus E to the power minus gamma. So these two are the equations, okay? And when x is equal to 0 means that the sending end. So if these are the boundary conditions, so if x becomes 0, in that case, what will be the value of v? V will be receiving and I will also be the receiving end current. So these are two equation 1 USA, equation 2. So both are receiving from starting from the receiving end side if we see. So this will be at x equals to 0, this is receiving and this is also receiving in current and receiving in current and voltage. So now what we can do is that if we plug in those values of 0 here, what we'll left out with, so V is equal to A plus B, right? And this is not V, so VR, and IR will be I by ZC A minus B. Okay. So based on these values, this consideration that at x equals to 0. Okay. So now with these two values, we can solve the value for A and B. So what we can do is that you can solve these two equations and find the values of we can find uh, values of A and B. I hope it's clear. We can solve these two values. In terms of VR, IR, we'll get these values, but we can solve. Okay. So the final expression of A and B, so A will be VR plus I, A will be VR plus IR ZC by 2, and B will be VR minus IR ZC by 2. So in that case, uh, this will be IR. Sorry, I mistake. I will be IR. Yes, I will be IR. So this will be IR. So in these two are the final expressions for A and B. Okay. So if we plug in these two values of A and B in these two equations 1 and 2, so we may rename it as 3 and 4. So if we plug in the value of 3 and 4, so we can get the final expression. So this much is required. So is it okay? Is it okay that the values of A and B are these two values?
Yes.
Huh. So if we do that, we will be so the equation. will be VR slash IR HC max plus VR minus IR HC. So this expression, we will have to keep this expression in mind. With that, we can switch to the numerical. I hope this is clear, and if we, as per the requirement, we will discuss. So let's start with the numerical, and accordingly we'll take the values one by one, which will be required. So this is the question from the book itself. You can of course refer to that. It is, single circuit, hertz, transmission line. Following parameters per kilometer. Okay. So the parameter values, uh, so R is 0.2 ohm, L is 1.3 milliamp, and C is 0.01 microfarad. Okay, so this term I forgot to mention. So this is the incident. This is the incident voltage, and this is called the reflected voltage. Okay. So in this question, single circuit 50 hertz three-phase transmission line has the following parameters per kilometer. Okay. So you may take a screenshot of this page because remaining question will also follow the same values, same parameter values. So you may take a screenshot because these values will be required for solving the remaining part of this question too. So, so with that, these parameter values are given in per kilometer. So this thing needs to keep in mind. And the voltage is given 132 kV. Okay. Line is open at the receiving end. Line is open, so this thing also need to keep in mind. So this is the final thing. So with that, we may start solving. I hope it's clear, right?
Yes, sir. We cannot assume lossless for this, right? We have to take it as
No,
lossy only.
no. For lossless line, it is not mentioned, no? So you cannot assume.
Okay.
And for this solving this part, I don't think you. Okay, yes. For ZC calculation, it is required. Oh, yes. So lossless you cannot consider. So that will be means you can consider, but the values I can't match because these values are not. I don't have the values of lossless. Since R and kV is
Resistance
given,
is given.
so R and kV is given. So in the upper this numerator, so we have for by calculating the characteristic impedance. This is this one is Y, means upper one is Z, and this one is Y, right? Characteristic impedance ZC. So one thing you can do for Y value in the denominator, the real part is not given. So in that case, you may consider in the denominator part only the effect of C. Okay. I hope it's clear, right? It's J omega C you can tell.
Yes.
This value is not given, so no need to consider this. Just this later on. Yes, I need it. And it is to neutral it is required in the question. The incident voltage is required to be calculated with respect to the neutral. So here in this value of 132 kV, it is line to line voltage. If nothing is mentioned in the bracket like line to neutral or anything, so in that case, always consider as line to line. So 132 is in line to line, so we need to convert that to. So okay, let's do it. Um, for characteristic impedance, Z is given. Z is given. R plus So for R plus JX, so series per unit length. So we can calculate value is 0.2, directly 0.2 value given, plus j omega n. J omega n so 100 minus 100 minus 0.1. So this is the impedance value. It will be final value will be this angle value it is given. It will be 0.454 angle 63.80. Okay. So this is Z value and shunt admittance. Shunt admittance can be given as j omega c. J omega c j into 2 pi into 50 and c value is given as 0.01 microfarad. So 0.01 so final value will be 3.14 into 10 to the power minus 6. And since j is there, so plus 9. So we have these two values. Characteristic impedance ZC we can calculate now. So with that final value of characteristic impedance is given. 3 minus 13.06. So, so ZC we have obtained IR. So the question in that case, when no load is connected, since for first and second question, no load is connected. So second question is to calculate the reflection voltage. Okay. Deflection voltage. Reflected voltage, not reflection. Reflected voltage. This is the incident voltage. The second question is to calculate the reflected voltage. But the line is given no load. So these values will be required for the third question. So don't consider that these values won't be required. So where is the calculation? Okay, another thing is for x length, suppose for x length we need to have these values. So gamma value is required. We got gamma. So what we will do now is to calculate the propagation constant value. So propagation constant gamma will be root under yz. So yz values, just plug in those values. Y and z value. Y value is this one. Y is 3.14 into 10 to the power minus 6, 90. 3.14 into 10 to the power minus 6, 90, and multiplied with z, and z is 0.454, 63.80. So final value we can calculate. So for square root. So what we are doing here, angles. What is the effect on the angles if we do square root? I hope you are clear with it.
By 2.
Yes, yes, great, great. So we can solve it. The final value I have with me, so I can these two values. Okay, propagation constant. So final value of gamma I am writing. Okay, so it is given as 0.2714 plus j into 1.169. So into 10 to the power minus 3. So this is the value given where this one can be treated as alpha, this one can be treated as beta. Since this one will be common for both. Given that this will be multiplied for both, this will be values of alpha and beta. So with that, we are now done with the expression with all the unknown parameters in this expression. So for given value x, we can also calculate now, which will be in the third question. But for the time being, in the first question, so incident voltage will be given as V. So incident voltage is VR, receiving end voltage, plus IR ZC by 2 VR plus IR ZC by 2. Now here, the since it is condition is at no load, because in the question it is given the circuit is open, so line is open, so line is open. Okay, so line is open. So at no load or line being open, so IR will be 0. So incident voltage we can directly calculate as VR by 2. Now VR is 132, so VR by 2, but the value of VR is 130. Huh? Hello, any doubt?
No, Shanti.
Okay, so 132 by root 3 by 2. Uh, since I guess it is a phase voltage, oh, RMS value only, not the phase voltage. Okay, we can keep it in line voltage. So 132 by 2. That's why the answer is 76. Yes. Somewhere somewhere it was written. Okay, yes, line to neutral given. Yes, that's why I also feel somewhere that line to neutral is required mentioned. So root 3. Divide by root 3 needs to be done. And if you do this, it will be coming as 38.1 kilovolts. So I think it matches, right? With you. Uh, Mixed up with all the. Just wait for one moment. I hope the recording is on this. So, so am I audible?
Yes, you are.
Okay. So you can do one thing. Just all the gadgets can be failure today. So I hope it's clear. From this part, it's clear, right?
Yes, yeah.
Okay. So moving on to the next part of the question. So reflected voltage value will be the same, right?
Yes, same.
Calculate the reflected voltage. So in this case also the value will be same. So minus So PMRF since zero, and the value will be 38.1 H. H to neutral. So same for both these. For the third question, for these questions, you need those values. A, B, and C. So the question is the incident and the reflected voltages to neutral at 120 kilometers from the incident. So this is the question. The incident and the reflected voltages to neutral at 120 km from the receiving end. So nothing much. It's a basic value that is being added. So this 120 km needs to be kept in mind and accordingly needs to be calculated. Right? So so both incident voltage and the reflected voltage needs to be calculated. Incident and the reflected. So we have those both expressions. What we can do is that directly we can plug in the values. Right? So incident voltage is incident voltage VR. So uh, this is the expression I guess. Yes, we are by so IR in this case also it will be 0. So IRZC multiplying value will also be reduced to 0. So here again the the final form simplifies to VR. So VR, line to neutral, again it is required. So line to neutral, line to neutral value will be 30 VR by 2. So VR by 2 is 30.1 kV, I guess, into e to the power gamma. So gamma is this one, this entire thing, and X is 120. Gamma value is given here. Need to convert it to so I have the value, final value, okay, so I can write the final value. If you are calculating, you can match, but you can do it later on. So for the incident voltage, what will be the value? Incident voltage value to neutral will be 39.25 angle 8.03. So you can match. Okay. I hope this will be correct because I am taking these values directly from textbook only. And the reflected voltage this will be section to the power minus gamma h. Right? This will be minus gamma h. So in this case also this is 0 and this one will be 38.1 this dr by 2 and e to the power minus this entire thing. So if we calculate these values, it will come as 36.80 angle minus. Okay. So these are the final answers. So these two are the final answers, right? I hope it's clear. You can calculate and have the values.
Yes, we'll calculate and verify.
Okay. So in case if the line loading value is given, so IR value will be multiplied and with the characteristic impedance, and the characteristic impedance values are, as we have already calculated, we can plug in those values there if it is required. But in this problem, since the no load value was the total given as a whole, so this thing didn't play a part. Okay, so that's it from my side. So I hope I tried to clear numerical issues or numerical assignments, doubts that you have. You may ask, otherwise we will conclude today's session.
Sir, one question. This
Right.
at rated load, like let's say at the rated load, we are given the certain power angle. Okay. And they are asking like, and then the sum it is given like it is operating the half the rated load. So it does not necessarily mean that the power angle will also become half, right? We have to do the calculation in the reverse way to
Yes,
find out the power angle.
yes. Because the power angle doesn't hold linear behavior, right? The
Right, sir. Just
if
wanted to.
the in form of equation, if you see the power angle doesn't hold linear characteristics.
Fine, sir. That's clear.
Ah, yes.
Uh,
So we cannot assume the means it won't be half. So you need to calculate.
Fine, sir. And just one more thing, like if the one of the problems in the assignment is wrong, like none of the four options are matching,
Okay.
then is there any process to report that or like
Yes, yes, yes. In that case, you have joined the Google groups, right? The Google groups mean it's a forum, Google group forum where you can post your queries.
the discussion forum, right?
You haven't joined, right? So you can do one thing. You can join that Google group in the assignment, not in the assignment, your NPTEL Swayam portal. You can log in and see in the initial days there is a link that will be given. So to join the Google group. So there you can raise this query, and in case this is found relevant that no options are matching, the TAs and it will be reported to professor. So in that case, the question will be resolved. So your marks will be not considered. Means this question will be dismissed. So in that case, your remaining questions will be evaluated. So you'll get
Okay,
the
sir.
Google group link. So you can check in your Swayam portal.
Fine, I will check and post the like
Yes,
query there. Yeah.
it's a group discussion forum. It's a discussion forum where people, the registrants do post queries or issues. You may post queries also there. So your questions or queries will be detailed or will be explained in detail, means with mathematical proofs as per the requirement of your question.
Sure, sir. Thank you.
Okay, then we can end today's session here and we'll meet on next Tuesday. Thanks for your participation.
Thank you, sir. Good night.
Good night.